Hello everyone and welcome to today's webinar, Migrating On-Premise Data Warehouses to Azure SQL Data Warehouses. I am Megan Souza, Marketing Manager here with Dunn Solutions Group. Before we get started, I would like to go over a few items. This session will be recorded and we will send out a link to the recording to everyone who registered within 24 to 48 hours after the presentation. We also have recordings of all previous webinars on our website in the event that you missed any in the past at dunnsolutions.com. Also, if you have any questions during today's presentation, we encourage you to submit them and we will address as many as we have time for at the end of the presentation. If the question is somewhat complex and we need more time to answer, we do promise to follow up with you for those. So let's take a look at today's agenda. I will begin by doing introductions to Dunn Solutions Group. From there, I will turn it over to today's first presenter, Jose Hernandez. Jose is the director of our analytics practice here at Dunn Solutions. Jose will begin with discussing traditional data warehouse challenges and then go into the Microsoft Azure Data Platform. After which, Jose will turn over the presentation to Sunil Parekh, one of our analytics consultants here at Dunn Solutions, who will then take us through a demonstration. After which, Jose will take a few minutes to answer any questions you may have. So let's begin. Dunn Solutions has a long history of delivering innovative business technology solutions to companies. We are headquartered just outside of Chicago and have offices in Minneapolis, Raleigh, and Bangalore, India. Our offerings fall into two practice areas. Our application development solutions feature portals, e-commerce, and content-managed websites, mobile application development, and custom application development. Our analytics solutions feature analytics and BI platforms as well as data warehouses and data integration. We are authorized SAP and Liferay training providers and offer classroom, virtual, custom, and private options. We believe training is important because once we deliver a solution, we want to make sure that those who need it know how to use it and maintain it. Our clients, some of which are included here, are a combination of Fortune 500, mid-market companies, government agencies, and nonprofits across all verticals. About 80% of our business is commercial clients and 20% about nonprofit and government. We maintain strong partnerships with top technology companies in order to offer our clients the most innovative solutions available today. Also, as today's presentation focuses on Microsoft, I would like to note that we are Microsoft Gold Data Analytics partners. Our analytics practice helps deliver information to decision makers throughout your organization so that it runs better. We can help you with decision making by not only looking into the rearview mirror, but also looking forward into the future by leveraging predictive analytics and data mining techniques. We've built solutions for our customers, which help them better manage their sales operations and inventory predictions, even helping determine where to build the next hospital. We make it easy for them to get the information using tools that don't require you to be a programmer, so that analysts and line of business managers can easily access the data they need to better run the business. Thank you for allowing me to introduce you to Dunn Solutions. I will now hand over the presentation to Jose. Welcome, Jose.
Great. So the question becomes one of, why would you put your data warehouse in the cloud? And that's a very good question. People have pondered this question for some time, and I think now is a very good time to consider this seriously with services such as Microsoft Azure and Amazon AWS. It's become a very viable approach to doing things, and for a variety of reasons. First of all, software as a service is not news. I'm sure many folks are familiar with Gmail and Office 365 and Salesforce.com, a variety of these services, where we are relegating the software and the hardware and everything required to use these kinds of systems to somebody else up in the cloud. And so we're becoming very familiar with that aspect and becoming more comfortable with it. So since much of your data is already in the cloud anyways, if you consider Salesforce as your CRM environment and many other sources like social media being up there, that's where the data is living anyways. And so now might be a good idea to go ahead and put your data warehouse in the cloud. The other thing I want to mention is in terms of maintenance and infrastructure. And while I don't like to put this at the top of the list, I do want to make it clear that if you do these services in the cloud, your organization, and think about this carefully, if you're a smaller or medium-sized organization, doesn't have to put out the cost, the capital cost and expenses of maintaining a data center, maintaining a computer room with the appropriate power and cooling and all the hardware, maintaining the right level of hardware that you need out there, growing the hardware as the demand grows. This is something that you don't need to worry about, and you really shouldn't have to, because unless you're in the business of building data warehouses like Dunn Solutions Group is, and building BI solutions, you're in some other business. That's not your core goal in life to do these kinds of things. So cloud makes a lot of sense for taking care of these kinds of solutions. Okay, so about 2 years ago, I did a series of presentations on data warehousing and what I'll call today is traditional data warehousing. We talked about the ETL process, dimensional modeling, all that fun stuff, and went through a series of about 4 or 5 presentations where we talked about how to do this. All that is still true, all that is still in play, and it's the world from where we're starting from in terms of having this discussion today. So a really quick recap of what's going on in traditional data warehousing, just to kind of set the stage. And what we have is disparate systems, transactional systems, where we need to go ahead and do analytics and reporting across the data that lives inside of all these systems. I've got some sales information in the sales system. I've got my customer relationship management system, maybe inventory, some finance systems. And really, to watch and run my organization, I need to access all of this stuff, and not just access it, but have it conformed in such a way that it's all lined up and makes sense. How much am I spending on that marketing campaign? How many employees are supporting a particular operation? How much money is that costing? How much revenue is that bringing in? Without having access to all the information from these systems and tying it all together, it's impossible, or very challenging, I should say, to answer these questions. And so what we do is we figure out, well, what are those questions that we need answered, and how can I put all that information into a central repository? And thus, data warehouses are born. And so what happens is we model the appropriate dimensional model so that we can consolidate and conform and clean that data. We use an ETL process to extract the data from those source systems, do whatever business transformation or cleansing transformations or conforming transformations that we need to do, and ultimately load it up into our target dimensional schema, which we can then toss our BI tools on top of, so that the business community can go ahead and glean that information and get the answers to those very important questions. And typically we've done this on-premise. A variety of our systems have been on-premise as well, so it seemed to make a whole lot of sense to do it that way. Well, the world is changing, and so the challenges, there are many challenges that are facing our traditional data warehouse model and the way we do things. It's not that we're going to toss out that whole concept, but we have to deal with some ever-changing forces around our traditional data warehouse. And the first thing I want to talk to is, and I'm going to try to do all this without saying the term big data. Gosh, I said it. I tried not to say it, but it may come out a couple more times. So if we think about the volumes of data in these systems that are out there, it is increasing. And along with those increasing data volumes, the sources that we can get valuable information from is also increasing. It's not just our structured data sources that we're accustomed to that we see in the bottom left corner, our traditional sales, CRM, inventory, and finance systems, but there's a lot of other relevant and important data that's out there, and it's typically not relational, it's typically not structured, but it comes from social media, it comes from sensors, it comes from various places in the web. And so how do we deal with these pieces of information as well, and how do we incorporate this stuff into our data warehouse? That's also a new challenge. I'm not going to toss out my whole business intelligence data warehouse concepts because these new sources exist. I just have to figure out a way of dealing with it and incorporating it into my solutions. So along with all this wonderful, fun new data and growing volumes of data that are out there, I also have more demand. And with more demand comes the need for more performance. And what that basically means is that the hardware and infrastructure that I had set in place that was doing just fine all of a sudden is overwhelmed. And what am I going to do about that, and how can I deal with it? Maybe my traditional relational database management system can't deal with these volumes of data. Maybe there's unstructured data that I can't contend with, and how am I going to incorporate that? It doesn't fit into my data warehouse. What am I going to do? And along with those the growing demand and growing need for performance is the growing demand from the business and user community saying, hey, not only do I want to do all these cool visualizations on my historical data, but I want to do some real-time analytics as well. And I want more horsepower. I want cooler, sexier tools to go ahead and dive through and navigate through and slice through my data. Well, that's quite challenging for the way that we've dealt with the data warehouse. So how can we possibly meet all these challenges? And there's a variety of things that we can do. And today we're going to talk about an exciting option that's available to us, which wasn't quite available so much before, and that's considering using Microsoft Azure as a platform to handle all these different things. So in terms of, and let's look at these various challenges that we had before. So we had the whole effort associated with having all this stuff on-premise. I've got to maintain my hardware. My hardware ages. I've got to refresh it. I've got to make sure I've got the appropriate cooling and power in a room. I've got to make sure that I have the appropriate level of storage capability on-premise. And I've got to maintain my operating systems. I've got to patch my software. It's quite a bit of work to do just to keep the lights on within my organization to run my on-premise solutions. I don't necessarily want to deal with that, especially if my core business has nothing to do with maintaining servers and building a data warehouse. I just need a data warehouse so that I can run my business effectively. And the other thing, if we talk about the growing demand and the growing need for storage and power, looking back at my data center or my room in the corner, depending on the size of my organization, now I need more stuff. I need more storage capacity. I need more processing power. Well, I've got to go acquire additional hardware to do that. I've got to set up that hardware. I've got to have staff in order to maintain that hardware and so on. So there's quite a lot of effort involved in just keeping this stuff alive and running. Well, with a cloud-based solution like Microsoft Azure, I take all of these, I'll call them challenges or pains, whichever word you want to use, and I delegate that and I relegate it to somebody else who's actually in the business of doing all this stuff. I don't have to worry about the hardware. I don't have to worry about the power. I don't have to worry about storage. I just ask for it, and within minutes, I get it. That's an amazing thing to have. Think about if you want to spin up a POC environment, and you need a cluster of Hadoop servers, or you need a large farm of SQL Server databases. With Azure, I simply can dream or imagine this, and I can click a few buttons, and within minutes, I have such an environment up and running, ready for me. And I pay for what I use, and I pay for what, and I can shut down what I don't use. And so on demand, I can completely control how much bandwidth I have. Part of the presentation that we're talking to today also focuses on Azure SQL Data Warehouse, which is it's kind of SQL Server, but it's a different version of SQL Server. So Neil's going to be talking more about that in a bit. All right, so we want to start with a baseline logical model of how we do these things with Microsoft technologies. And I'm not going to talk about cloud or on-premise at this point because this is a logical concept. So I have a variety of source systems which are running in various databases. Let's say that they're SQL Server, since it is a Microsoft-centric presentation today. And from those source systems, I want to stage my information. And so basically, I'm going to extract that information from those source systems and stage it in maybe another SQL Server database. And so now that I've got my staged environment in SQL Server, I want to go ahead and move that information and do the appropriate transformations and cleansing so that I can consolidate it and store it in SQL Server Data Warehouse, which is what we're going to talk a little bit about in a minute. It's a massively parallel processing environment that's basically built for speed and built for volume. So we'll talk about that in a bit. And ultimately, what do? I might create some cubes where I go ahead and build reports off of, or I might query directly against that database using SQL to do some analysis off of as well, and to maybe even build some reports. So this is the logical basic architecture of our Microsoft BI solutions. Okay, so now that we talked a little bit about the Microsoft-centric solution for data warehousing, we talked about traditional data warehousing and some of the challenges, let's talk a little bit about the Azure platform, specifically the various things that we can do with Azure in business intelligence. And what you'll notice is that our simple diagram of the traditional data warehouse, if we look over to the right, it looks a little more robust and full of features. So if we think about dealing with data sources, if we think about dealing with non-structured databases and non-structured data and streaming data and social media, how do we handle all that stuff? How do we handle the bandwidth of the additional network traffic? How do we handle the bandwidth on power demand in terms of processing power and storage? So the Microsoft Azure Platform gives us the ability to do all that and handle it in the cloud and handle it in an on-demand kind of way. So our data sources, doesn't matter where they're coming from, whether if they're coming from an on-premise database, we can get those moved into a staging area within our Microsoft Azure. Do we need massive databases to handle large data volumes? We can certainly do that with HD Insight, which is the big data component of Azure. We can also do it with a version of SQL Server, Microsoft SQL Data Warehouse, which is going to be the star of our show today, and talk about that. We also have the ability to do real-time analytics and predictive analytics and historical analytics, the traditional analytics, and combine that with a variety of applications and service users, whether they be on tablets, on smartphones, or on desktops or laptops. The Microsoft Azure platform lets us on demand deal with any of these scenarios very, very quickly and effectively. So I'm about to turn it over to Sunil, who's going to talk a little bit about the Azure SQL Data Warehouse and how that all works. And he's also going to dive into a demonstration of how we can get on-premise data into the Azure cloud and then take advantage of some of these capabilities, and we'll see him do that live. So Sunil, without further ado, I will turn it over to you.
Thank you, Jose. Okay, can you give me a control? Okay. Hi everyone, and welcome to this webinar. I'm Sunil Parekh, Analytics Consultant at Dunn Solutions. First, I will explain the architecture and feature of Azure SQL Data Warehouse, and then I will demonstrate on-premises data warehouse migration to Microsoft Azure. So let's start with the Azure SQL Data Warehouse architecture. So Azure SQL Data Warehouse, it's a multi-node, massively parallel processing engine which supports petabytes of data. As shown in the diagram, it consists of a set control node which controls the multiple compute nodes, which are nothing but a SQL Server databases. And the data gets stored in the Azure SQL blob in a table format. The users or the applications can connect or execute a query to the control node, with the query get distributed across multiple compute nodes, and each compute node then parallelly execute that query and provide the results back to the control node, which can be accessed by the user and the application. The data loading into these nodes can be done by the different methods like SSIS, Polybase, PCP, and the data gets stored in a table with the column store index format, which stores the data with the compression, and it is optimized for the read performance, which is required in the data warehousing purpose. Since the data is loaded in a table and which gets distributed across the nodes, Azure Data Warehouse supports two algorithms to distribute the data across the nodes. The first is a round-robin method, and the another is a distributed method. In a round-robin method, each row in a table gets distributed across rows equally, And in the distributed method, each row in a table gets distributed across the nodes using the hash function. The hash function can be a primary key, a date, a client ID, which is based on the scenario user can define. So this is the architecture of the SQL Server Data Warehouse. Let's understand the features of the Azure SQL Data Warehouse. As discussed, Azure SQL Data Warehouse, it's a petabyte scale with a massively parallel processing engine. It's independent of scaling in compute and storage. So you can add multiple nodes, or you can put anonymous data. You can store large amount of data into the storage, and you can scale up and scale down that. It also supports the transact SQL queries across relational and, importantly, non-relational database too. It's a full enterprise class SQL Server experience, and it works seamlessly with the Power BI, machine learning, SD Insight, and the data factory. So this will be our data storage for the SQL data storage for our data warehousing, and we are going to use Azure SQL Data Warehouse as a data repository for our data warehouse. So let's understand how the solution will look like into Microsoft Azure using Azure SQL Data Warehouse. So as shown in the diagram, we are going to use Azure SQL Data Warehouse as a data repository where all the data from the different sources will be transformed and loaded into the Azure SQL Data Warehouse. The different sources which may be on your premises or already in the cloud can be replicated to the Azure SQL database, which is a database in a cloud. That can be a part of your cloud strategy. So once the replication is done, we will pull all the incremental data from these replicated servers to Azure SQL Data Warehouse using ETL tool SSIS. Once the data is loaded into Azure SQL Data Warehouse, the cube which is pointing to Azure SQL Data Warehouse will be processed, and which will store all the updated data and the aggregations related to that data. SQL Server Analysis Service solution, which is already is there, we'll migrate that to the cloud, and which will start pointing to the SQL Server Analysis Services. SQL Server Integration Services, Analysis Services, and the SQL Server Reporting Services will be deployed in the Microsoft virtual machine with the SQL Server instance, which will be used in the on-premises with the same version. For the business users or for business analytics, the Power BI solution is there, which can also connect with the SQL Server Azure Data Warehouse, and the different dashboarding or ad hoc reporting can be created using Power BI. So I'm going to demonstrate all these key components in my demonstration. So let's move to the steps to migrate your on-premise data warehouse to this new architecture in Microsoft Azure. So in the demonstration, we have simplified the architecture but included all the BI components which are required for data warehousing. I will demonstrate the data migration from on-premises data to this Microsoft Azure SQL Data Warehouse. Then I will demonstrate the data integration using SSIS, and I will also demonstrate the integration with SSAS, RS, and Power BI with SQL Azure Data Warehouse. I have used AdventureWorks data for this demonstration purpose. So let's understand what are the steps performed for the migration. The first step is to migrate existing data warehouse database to Azure SQL Data Warehouse. Once the migration is done and all the current data or the data is in the Azure SQL Data Warehouse, the second step is to start the replication, set up a replication and start that data flowing from on-premise data to your SQL Azure databases. Once the data is started flowing into Azure SQL DB, the incremental data will be processed. It extract, transform, and load using SSIS into Azure SQL Data Warehouse. So that's a step 3 where we are setting our ETL processes. Once the ETL process is set up, the next step is to process a queue with which is pointing to Azure SQL Data Warehouse, and all the data get calculated, aggregated into the SQL Server analysis services. And then the next step is to point the SQL Server reporting services to analysis services, which is already deployed in the Microsoft Virtual Machine SQL instance. And then we have perform or create a dashboards, reports using the Power BI, which can connect to SQL Azure Data Warehouse. So these are the steps performed where you are migrating your existing Microsoft BI solution to the cloud, and each component is migrated into the Microsoft Azure. So let's start with the demonstration of this migration. So I will use the same slide for the steps to be performed. I'm going to perform for this. So let's start with the step 1, which is migrating data from on-premises SQL Server to Azure SQL Data Warehouse. So for this demonstration, for this migration, I have used Data Warehouse Migration Utility, which will transform data from SQL Server, which is on-premise, to the Azure SQL Data Warehouse. So let's connect to the on-premises database. Once I'm connected to the database, all the data warehouse or databases will be showcased. So I'm selecting the AdventureWorks Data Warehouse to migrate to the cloud. Once the selection is done, it will showcase all the tables, which are mostly dimensions and the fact available in the data warehousing solution. So for the demonstration purpose, I'm selecting few dimensions and one fact table, which is fact internet sales, to migrate to Azure SQL Data Warehouse. As discussed, we can also select the table type, which is round robin or the distributed, based on your case. It's mostly we can use a distributed for the fact table or the large tables. For the demonstration purpose, I'm just keeping this setting as it is, and I'm selecting to migrate these tables to Azure. To migration, the first step of the migration is to create this structure into Azure SQL Data Warehouse. For the demonstration purpose, I have already created a SQL Data Warehouse, which is set up, and I can just quickly show you that, okay, we can actually add a scalability to it, and we can also pause this structure. So this structure it's already been created with the instance which I have already created in the Microsoft Azure. So next step is to load a data into this table. Just notice that the table is created with the column store index and with the distribution method, which is provided in the migration utility. You can copy or save this script for the future reference also. So let's move to migration of data. So there are two methods supported. I'm going to use BCP for the migration. So this utility will create BCP packages at the provided location. So let me provide the location, and which also requires a database connection of SQL Azure database. So I'm connecting to the Azure Data Warehouse to provide a connection to BCP packages. Okay, so BCP package are generated successfully. Let's go to that folder where it's generated. So So data migration from on-premises to Azure SQL Data Warehouse, it's a two-way BCP process. The first process will export all the data from the tables to a file, which are generated. For the demonstration purpose, I have just selected few. The next step is to import that data into Azure SQL Data Warehouse in the cloud. So now this process is actually moving the data from this file to SQL Server Data Warehouse. As discussed, it's just not moving, it's also based on the number of nodes configured in the cloud. It's also distributing the rows in the particular table across the nodes while loading it. So its data gets just not loaded into one node, but it's loaded across the node based on the distribution method provided. So this process will take few more couple seconds. So let's wait for that. Okay, so data is now loaded into cloud. So I have just taken this. So this is a Power BI report which is pointing to Azure SQL Data Warehouse server, and I refresh it before the loading the data, and it was showing nothing because there was no data we have uploaded into that. So let's refresh it to verify if the data has been uploaded to the Azure SQL Data Warehouse. So see, all the data which were on your premises now it's available in the Azure SQL Data Warehouse, which we can now also see in Power BI report. So let's move to the next step. So this is the first step where we have done the data migration from existing warehouse database on-premise to Azure SQL Data Warehouse. Next step is to set up a replication, which I have already set up and created a Azure SQL Data Warehouse database, which is already set up in the Microsoft Azure. Next step is.
Neil, I have a quick question. So you said you set up Azure SQL Data. You set up those are regular Azure SQL Server databases.
Yes, that is true.
All right, thank you.
So the reason behind using the Azure SQL databases, so whatever the database is, assuming it's a Microsoft BI solution, and your databases are in the Microsoft SQL Server. So as a part of the cloud strategy, and since we cannot access directly your production databases for the ETL purpose, we need to replicate that. So we can replicate either on premises or the best option is to replicate to Microsoft Azure so that we can use it directly use it for the ETL purpose, and it's also create a copy of your production database. That's the advantage of doing so. So the next step is so once we start this replication, the data is started flowing into the Azure SQL databases, and we have to pull only the incremental data from this database, from the multiple systems to Azure SQL Data Warehouse. So we will use the ETL SSIS for the ETL purpose. So for the demonstration purpose, I've already set up a database, and I will add few records into that database for sales orders, and then I will run the SSIS package, which is deployed in Microsoft VM to migrate this data from your operational system to data warehouse. So let's move to the data. So here I'm just inserting a few data. So I have already created AdventureWorks transaction database in cloud. So I'm inserting few data into it. So data gets inserted into Azure DB. So next step is to run the SSIS package. So before that, just notice in the same report or the dashboard, we have a data up to 2008, and then I have just added a data for 2009, which I'm going to ETL using SSI. So this is the existing solution, which is now the target is now pointing to your Azure SQL Data Warehouse. And I'm going to execute this package, which will populate the fact table, which is with the sales order. So the data gets populated into SQL Azure Data Warehouse, and let's confirm it by double checking our Power BI report. So let me refresh it quickly. See, now the 2009 data is also available in the Azure SQL Data Warehouse. So your reporting solution, it started pointing to the SQL Azure database, and the ETL is working, which is loading the incremental data from your transaction system to the SQL Warehouse database. This is how we have completed step 3, which is loading the data, incremental data from transaction system to SQL Azure Data Warehouse. Next step is to process a cube, which is pointing to the SQL Azure Data Warehouse. And to do that, we have already set up the SSAS queue into the cloud. But before that, I will also want to showcase you the report, which is now pointing to the SSAS queue, so that we can see the difference of data which we have processed through it. So let me move quickly to my VM, where the SSRS setup is also there. So right now the SSRS report, which is pointing to the SSAS cube, it's showing just the data up to 2008. Now let's move to our SSAS queue. So, and then process the cube. So this processing will actually take all the data changes happened after the last processing from the SQL Azure database, and it will process and create all the aggregations with the new incremental data into cube. So cube processing is done, and now data is also available in the SQL Server Analysis Services. Now let's quickly verify our report. So your reporting services also start reflecting data which is processed, the 2009 data which is added incrementally into your transaction system. So let's go back to step 5, which I have already demonstrated. So your SSRS solution, which is already deployed to virtual machine SQL instance, and which is now pointing to SSAS. And let's move to the last step, which is the creating of dashboards using Power BI, which is pointing to Azure SQL Data Warehouse. So this is the dashboard which I was used for the demonstration purpose, but I have another dashboard which is right now pointing to SQL Azure database, and then you can just drag and drop and then create this dashboard, and you can actually analyze the data based on the filters, and you can do this interactive reporting using Power BI, which is pointing to Azure SQL Data Warehouse. Now, since the Azure SQL Data Warehouse, it's a parallel processing engine, and this Power BI is pointing to that. Based on the performance required, you can scale up and down the Azure SQL database, and your reporting performance will not hamper in terms of the peak load. At the same time, if there are not multiple users connecting to your reportings or Power BI solution, you can scale down your Azure SQL Data Warehouse database. So that's the step 6, which we perform for the migration, and that's it from my demonstration. Let's quickly recap what we have seen in the demonstration. So in the demonstration, the first step was to migrate the existing data warehouse data to Azure SQL Data Warehouse, which we have done using the migration utility. Then we have set up the replication between on-premises data to Azure SQL DB. Then we have run the SSIS, which move the data or which incrementally load the data into Azure Data Warehouse. And then we set up the SSAS solution and process that SSAS solution, which process all the new data from SQL Azure Data Warehouse. And then we saw a couple of reports using SSRS and the Power BI. So in Microsoft BI solution, which is on premises, uses the SQL database, SSIS, RS, and IS components, which we have migrated now to the Microsoft Azure platform. That's from the demo. Back to Jose.
Thanks, Sunil. Very fun stuff, and especially if you like to look under the covers of how this stuff works, it's a very good peek at what's going on under the covers. All right, so as we get the last few slides up and running here, I want to revisit and go back to the question, so why would you put your data warehouse in the cloud? Well, early on we talked about a variety of the reasons, but probably the most important one is there's a lot of work that goes around supporting and maintaining and paying for the infrastructure to support these data warehouses, especially these data warehouses as they get very large. And being able to start projects on demand and to change to deal with peak load or low loads is something that is quite challenging, but actually something very easy to do in an Azure environment. I was talking to Sunil earlier about what was involved in setting all this up. He set up the Azure infrastructure to do all this. Now remember, that's 2 SQL Server databases, that is Power BI, that is the Azure SQL Data Warehouse, and he got that all up and running and spun up in a matter of hours, which is something that if you think about going to your IT department, and I know that they do a great job, but if you ask them to set something up like that for you in the morning because you wanted to go ahead and set up a POC, they would look at you like you're crazy. I can't get that done for you in that kind of time period. But with solutions like Microsoft Azure, you can set up environments like that on demand, and you only pay for what you use. So it's very cost effective. It's very convenient. It's also a very good long-term solution. So we also talked about, is this a good place for me to have my data warehouse? A bunch of your data is already in the cloud. A bunch of your data is going to come from social media. It's going to come from internet-connected devices. So it simply does make sense to already have your data warehouse up in the cloud and to be able to deal with the streams and the bandwidth of data that you'd have to contend with. That's another thing that you don't have to worry about compared to being on-premise. So with that all said, I wanted to thank everyone for attending, and a couple final words before I open it up to questions and answers. If this is something that's interesting to you, if you haven't thought about or just started to consider, hey, do I want to do something like this? Do I want to build my data warehouse, or even just a POC data warehouse? Do I want to do that in the cloud? Do I want to use the Azure to go ahead and do my next BI project and see what that's like? We certainly would love the opportunity to help you get there. Our experts love working with new environments and with new customers to go ahead and watch the light bulb go off when folks migrate their data marts and their data warehouses to the cloud and start using it in that fashion. So by all means, please feel free to reach out to us. There's an email address there, info@dunsolutions.com, which you can generically reach out to us, and it'll be forwarded to the appropriate person. So I think now if we'll check and see if there's any questions. And Megan, if you could look at that list there and see if any questions are sitting out there.
Okay. Looks like we do have one for Jose. Do we need to create SSAS queue?
Got it. So one of the things in the demonstration that Sunil did, and you saw that, is that he had the Microsoft Azure SQL Data Warehouse, where he was storing his dimensional model, his fact table, his dimension table, and then he also populated a queue. You do not need to populate a cube. It's just that the SSAS is one of the features of Microsoft that people take advantage of, and so that is an optional component. Once you've populated your data into that Azure SQL Data Warehouse, you can directly go against that and use your Power BI or whatever other BI tool that you might want to use to go against those tables directly.
Okay, very good, thank you. If anyone else has any other questions, please feel free to type those in the chat box. Okay. Unless you've got any further questions, please go ahead and for any follow-up that you need, email info@dunnsolutions.com. I want to thank both of our presenters, Jose and Sunil, today. Very insightful presentation. And thank you all for joining us today. We hope you enjoy the rest of your day.